Now we look at deleting from binary search tree. So here is an example binary search tree. Let's see how to delete any key. So I'll take various examples and show you. So first key I want to delete is 25. So what is the procedure? So the procedure is search for the key. If found, then delete it. That's simple. Search for 25. Start from here. 25 is smaller. Go here. 25 is greater than this. Go to right. Yes, found. Then delete this node. If you delete this node, any node, then you have to make its parent link as null, right? If it is linked representation, we have to make this as null. Yes, we can make it as null and this node is deleted. So this was simple. I'll put back the node as it is. Now let me take another example. I want to delete a key 43. Search for 43. 43 is greater than this and greater than this one. Less than this, come to left. It's greater than this. Yes, found. So delete the node. Then make this right child link as null. That's it. So node is deleted. So I'll put it back. So these were simple examples. Next, I want to delete a key 42. Search for 42. 42 is greater and this is smaller than this one. Yes, found. Now the problem is there. What is that? If I delete 42, then I have to modify the link of parent. But 42 is also having a child. Then, okay, it is having just one child, no problem. Its child will take its position. So if 42 goes away from here, then this will be pointing onto its child. That is becomes a left child of 45. So we saw one more thing now, that if the node is getting deleted and if it is having one child, then that child will take its place. So again back to the same tree. So the procedure we have learned so far is, if you want to delete, search for the key. If found, then delete the key. If it is not having any children, no problem. If it is having one child, then let that child take its place. Now what if I want to delete key 30? I want to delete this. Then after deletion, who will take its place? You may be saying 20. Then who will take the place of 20? 25 or 10? Anyone? Or else I say that no, 40 will take its place. Then who will take the place of 40? 45. Who will take the place of 45? 40. So many changes we have to make. Instead of doing this way, the other way is, for 30, find out in order predecessor. Means if you perform in order, which node comes before 30? So 25 comes before 30. This is in order predecessor. And who is in order successor of 30? Who comes after 30 in order traversal of this tree? This one. So this is in order successor. So there is in order predecessor, there is in order successor. So for a node, this is in order predecessor, this is in order successor. If you are deleting 30, 30 is going out, then either in order predecessor will take its place or in order successor will take its place. So in order predecessor may be a leaf and in order successor we assume it is a leaf. Yes, they are leaf. So leaf node will come into its place. So we don't have to disturb so many nodes. So the result of this tree can be 25 as a root and 20 and 10 on this side, 40, 35, 45, 42 and 43. It can be like this. So where 25 is in the root, or it can be 35 in the root, 35 is in the root. Either 25 is in the root or 35 in the root. See here, from here the node is deleted and here, from here the node is deleted. So this is the actual method. When you are deleting any node, then who should take its place? In order predecessor or in order successor should take its place, right? So how to find in order predecessor or successor? For in order predecessor, for deleting a node, go to its left subtree, left, then right. So the rightmost child of a left subtree. In order successor is leftmost child of right subtree. So you can easily find in order predecessor, in order successor. You don't have to perform in order traversal. You can go to left subtree, then right until you find the last node. Or else go to right subtree, then left until you get the last node. Then, so that's how you can find in order predecessor or successor. Now one more question remains. Shall I take in order predecessor or shall I take unordered successor? You can take any one. You can take any one. It's your choice. Suppose you want to say that no, right hand side is having more elements, so from there I will bring. Okay, so you can count the number of nodes here and you can count the nodes here. Whichever side is having more number of nodes, from there you can get it. Or else you say no, the height of this right subtree, this portion is larger than this one, then if you want to take this, so find out height and select that one. So otherwise randomly you can select any one. So we have seen various examples, and when we took 30, then we understood that we have to replace it with in order predecessor or in order successor. Then what about 25? When I deleted 25, there was no predecessor successor, right? So directly I deleted the node. Then what happened when I was deleting 43, there was no predecessor successor, so directly I deleted it. What happened when 42 was deleted? When 42 was deleted, there was only one child, only successor, so it has taken its place. So actually I was following same method, right? Always we should follow same method. Now I'll remove this and I'll show you one more example. Suppose I want to delete 40. Then after deleting 40, who will take its place? In order predecessor. Who is in order predecessor? This one. See the nodes below 40 only. Then who is in order successor? This one. This is in order predecessor, in order successor. Suppose after deleting 40, I want to bring successor here. 42 will come here. This 42 will come here. But 42 is still having some child. It is not a leaf node. It's not a leaf node. Then I should fill up this position also with its in order predecessor or successor. So there is only one node that will come in its place. So listen carefully. We were taking in order predecessor or successor because we wanted to avoid multiple modifications in the tree. But this is the example where though we are taking in order successor, we have to make multiple modifications. This is gone, 42 has taken its place, then 43 has to come here, right? So if the in order predecessor or successor is not a leaf node, then you may have to make multiple modifications, right? So quickly I will show you one more example. Suppose this is a binary search tree. I want to delete 10. Then there is no predecessor. Successor is there. Who is in order successor? 20. So 20 should go there in place of 10. Then this will be vacant. See, this is not a leaf node. Then who will take its place? 30 is a in order successor of this one. So 30 should come in its place. Again, this is vacant. This is not a leaf node. Again, it's having a child. So 70 should come here. So in this example, we have to make more than one modifications if you are deleting some node in a tree. Now, analysis. What is the time taken for deletion? It depends on the height of a tree. We are searching and modifying it. So it depends on the height of a tree. We say height is log n, right? We are assuming that it is log n. Then after deleting a node, how many modifications required? If predecessor successor is a leaf node, then just one modification. Otherwise, there may be more than one modifications. How many at most? That depends on the height again. So that depends on the height. In this example, you can see that depends on the height. So number of modifications are also log n. Time is log n and the number of modifications may be maximum log n. So that's all. Let us summarize all the things. Then once again, I will show you what all we have done. Let us look at these cases. See, if you are deleting 10, so there is nothing below 10. This is a leaf node. Simply delete 10. Second one, if you are deleting 40, then 40 is having one child. So let that child take its place and delete 40. Then third, if you are deleting 30 and there are both left subtree as well as right subtree, right? Then let in order predecessor go there or in order successor go to its place. Now fourth one, if you are deleting a node and if you want in order successor, then this will go in its place. Again, if it is having children, then its in order predecessor or successor will come to its place. More than one modifications required. So actually there is only one method, this one. When you delete, bring in order predecessor or successor, anyone. If not there, then these are other two cases. And if it is also having its children, then modify that also. That's all about deletion. We will look at a program how to delete.